Attention at the front of the room, please. There you go. I hear them coming in. Where am I at? Today's assignment is abstraction. We'll talk about that in a little bit, but we're going to get to the point. The standard is MSCSFCP3, and it's to utilize computational thinking to solve problems. All right, take your earbuds out your ear. This is the second time I've asked. Thank you very much. The standard itself or the element is develop a working vocabulary of computational thinking, including sequences, algorithm, binary, pattern matching, decomposition, abstraction, parallelization, data, automation, data collection, data analysis, booleans, integers, branches, if then and else, and iterations, loops, for, and while. So now that's a lot in one big jump. So what we've done over the week before you went on break was we broke it down. You had to define these words, and then we talked about sequencing, right? Sequencing means to do what? Take one in order, one step, one process after another, in order. That's all it is. All right, it's just like my granddaughter did the scratch this over the break, the first part of the break when she was interested in it, and she did. I'm gonna see if I can find it. The bear. And she realized that there was a sequencing code, it might not be in this one, yeah, for the bear, and she could make him walk. Let me pull him back, and if you watch his legs, one step after another. It's a process, a simple process. Some of you have this in your game already. Somebody had it in their game where the cat walked up to the van, and then the van moved, steps, processes. All right, one thing happens after another. It's just that simple. Now, in the same context, when we start talking about sequences, there's algorithm. What is the algorithm, Mr. Pope? Algorithm. Algorithm.
Letters?
Nope, not letters. What is algorithm?
It's like an equation.
An equation? Yeah, I can go with that. Talk to me. Talk to me. Yeah, if equation wasn't wrong, you know you can't be too far off.
Operations.
Operations,
Expression.
expressions. All right. It's putting it together, making things happen. In math, it's 2 plus 2. All right, algorithm, putting it together. We'll get a little bit more than that. Then we'll talk about binaries. Binaries is where we're at today, and that's where I'm gonna put the main part of my focus. And then we'll move to abstraction, which sort of come with decomposition. Think of decomposition, you think of science. But before we get there, let's back up. Binary. Bi means what in English?
Sexual.
One.
Okay. No, the word sexual is totally different. But it means what? 2. Bi means 2. Binary means 2. Now understand this.
What's it by yourself?
Row 1. Thank you. Thank you. If binary, it means 2. So in math, in binary and computer science, it is for us the number zeros and the number 1. You remember seeing that? Remember we talked about that a little bit? Okay. Hope, I'm this way. I appreciate you. If you don't have answers, you might need to be paying attention. So with 1s and 0s, you start thinking about the squishy games that you did, the squishy circuits you play with, and 1 or 0. Which one we got here? A 1 or a 0?
1. 0.
Why is it a 0? Because nothing is on, so it's off. So if it's off, it's a 0. So just the opposite of that means that if it's on, it's a 1. A 1. Now we can look at this in English. If it's true, it is. Is it a 1 or 0?
1.
1. So if it's false, it's a 0. Does that make sense?
Yes.
Now, that's the simple part. So when you start looking at your coding for your game, is it on or is it off? That's what you're gonna ask yourself. All right. So if I wanted the second object to move, is it on or is it off? What cuts it on? What cuts it off? Those are the type of things I'm starting to ask. Look inside this one. All right, let's press the flag. All right, notice it's talking. But at certain points, certain things are on and certain things are off. Because when it first starts, it doesn't start with everything being there. All right? So it came on, and then somebody said, what's your name? That became on. And then after a few seconds, the girl says Taylor. That becomes on. So when is it on? When is it off? Yes or no? Take your head off, baby. But what I want to do with you today in binary codes, and we're going to talk about bits and bytes, which comes under the term, but it doesn't show up right here. All right? A byte, a bit, B-I-T. It's just one. It's single. Yes or no? On or off? Does that make sense? One bit. You can have one choice or the other. When you did the squishy circuits and you connected the connectors, it was either connected or not connected. One bit. Does that make sense? All right. Talk to me. Huh? Okay. We'll see if we can get to do it today. We'll hopefully we get around to it. Now, what we're going to do after bits is we're going to look at bytes. This is 8 all together. So you got a bigger circuit to deal with. You got more choices. I can go from off to no, partially on, completely on. Or I can flip it where one is on or the other one is off. So it depends on how I code it as to what I get. I have more options. Does that make sense? Mm-hmm. All right. So now with that being said, there's a table. You have to use this binary table when you start coding or writing codes or programs for your binary numbers. The table goes in reverse. We count 1, 2, 3, 4, 5, 6, 7, 8, right? The table starts at 1, but after 1, the numbers double, and it goes the opposite way. So then we get 2. What we get next? 4. Next. I only got one person in class. One person in class still.
Oh no, I'm just sped, so I don't know.
Your class is up there then.
So what, baby? So what'd you say, Adrena? 32? What comes after 32? 64. I'm going to stop here. You have seen these numbers. All right? When you start buying storage, you can get 1, 2, 4, 8, 16, 32, 64, 128, 256. Those numbers start looking familiar to you?
Gigabyte. Yeah.
Gigabyte. When you're buying storage or buying flash drives or buying CDs, anything that you're going to use to store your information, Pope, I'm in front of you for the second and final time. All right, so that's what we're looking at. But now when we start to code with this stuff, remember, it's either on or it's off. So I have to figure the value of what I want to code. If I wanted to code the number 1, all I have to do is make 1 on, and that equals 1. Does that make sense? Mm-hmm. But now if I wanted to code the number 5, how do I get the number 5? What's the biggest one I can use for 5? 4. So the 4 is going to be on. So we got 5 minus 4 leaves us what? So what else is on?
2.
Is the 2 on?
Yes.
So we're trying to equal 5. Basic math.
4 plus 1.
4 plus 1. So what else has to be on other than the 4? The 1. So the 1 is on. And the 2 gets a 0. So that is 5 in binary code. Does that make sense? Give me computer science is math. Give me another number. Keep it small so you can be simple with it. 10? Okay, we're gonna use the number 10. What's the biggest number we can use up here to get 10?
8.
So the 8 is on. So 8, 10 minus 8 leaves us.
2.
What else is on?
2.
Keep your hands to yourself, boy.
1.
The 2, I'm sorry, I'm putting the 2 here. The 2 is on. So the 4 we don't use, the 1 we don't use, so they get zeros, and that's 10. Does that make sense?
Yes.
Half of you got it, the other half we playing don't get it.
It's kind of making sense.
It'll make more sense if you leave you alone. Don't look at me like you don't know I'm talking to you. Okay. Your hands, you can stay to yourself. I'm gonna tell you one more time. Now, give me one more number.
11.
2.
16.
8.
Which one we want? 11, 13, or 8?
13.
8.
13. 44.
34?
44.
44?
21 sounds like a good number.
21 sounds like a good number? But we can do 21.
No, it's 44.
21 and then we'll do 44 and we finish. Okay, so where we gonna start for 21? What's the highest number we can use?
16.
So the 16 is on. So 21 minus 16 gives us what? How many?
5.
5. Where do we go next? 5. What's the biggest number we can use?
4.
The 4. So the 4 gets a 1. We're not going to use the 8. It becomes a 0, right? It's off. So we got 5 minus 4 leaves us. And what number do we use next?
1.
The 1 is on, so it gets a 1. We didn't use the 2, so it gets a 0, and that's 21.
10, 1.
All right, so now let's try 44. Where are we going to start?
32.
32 gets a 1. I got to subtract. Y'all know how to do this now. So I got 12.
Well, she copied. And then you gotta do the 8. You gotta use 8.
I got to do the 8. So what happens to 16? It's off. What number do we use for off? 0? Okay, so we got 8. 12 minus 8?
4.
What do we use next?
2.
We're going to use the 2?
Yes, 2.
Our number's 4. Look at our.
4.
We're going to use the 4. The 4 becomes a 1. So the 2 and the 0 becomes, and the 1 becomes 0, and that's 44. Now, with this here table, I want you to write it, and I want you to calculate your age in binary numbers. Oh, yeah. Let me see. Somebody's age might be up here?
No.
We good.
I'm 16.
That's why I didn't use 12.
I'm 16. I'm 13.
You 94.
Actually, I'm
64.
You better be figuring. I'm coming to look at it in 1 minute. Use your Google Docs. Back row. Back row.
You gotta take that.
Your age in binary terms.
What's a binary term?
You got one more time. Have I like in my classroom? When we have this conversation with your parents and I rerun this video, you can explain to them why you don't know. Because I mean, I understand we just came back from break, but that's not what you're gonna do.
Okay, so I need to write.
Write your age. You might want to do the table. That ain't what I did.
But it's similar. That is.
That's not what I did.
1.
Okay. Should be a Google Doc.
He was supposed to.
I'm saying 8 she gives me 5 minus 4 equals 1.
Now put your A to the side like I did on 4. And then plug it in. Remember I said the table go back? Remember your table go back? Guys, remember the table for binary numbers go backwards. It doesn't start with the low number and the higher numbers go to the right. The higher numbers go to the left. Come on. Google Docs, and let me see you doing it. Good job, darling. Nice start.
I'm not buying.
You better focus.
It's not that.
I think it's
I don't care what you do, as long as I'm seeing it. The thing is, I'm not seeing it.
I'm finished.
I'm.
You 12?
Baker.
So when you get ready to do this to go out the door, you don't know what you're doing, you got that zero, I want you to understand. I don't babysit. Alright, somebody, I heard somebody say that 12. How do we write 12?
minus 8.
Huh?
Minus 8.
8?
Because you gonna say you don't understand.
4.
I got the one on the 4. What's that?
You can subtract about 2.
Huh?
You can subtract about 4.
Okay, y'all, what is she doing wrong? What comes after this? If we don't use it, what do we do?
Put a 0 on.
It's either on or it's off. It's either being used or not being used. And she's right. 8 plus 4 is 12. But we didn't use the 2 and the 0, so we couldn't just leave it open. The computer can't read an open spot. What it sees is if you're looking at a DVD or a CD, and every time you write on that screen, it puts an indentation in it. So what it does is either it's on or it's off. So if it's on, it's the indentation, then it get a 1. And if it's off, it gets a 0 and it keeps reading across it. So right here, when it get here, it's going to get confused if there's nothing there. Does that make sense?
Yes.
All right, so now somebody give me another number. Anybody, any age other than 12? 13? 13? Hey, we don't have to do that. I can put both, I promise you. We can do 13 and then we're going to do 15. Your behavior got to get a little bit better in the back. 13, what am I doing?
8 first.
8?
I got an early bird. And then, 4. 12. Yeah. And then 1. Yeah.
What happens to the 2?
You gotta put a 0 right there.
That's 13. What's my, who gonna do 15 for me?
I'll do it.
Talk to me.
Never mind.
What's the highest number you can use?
8.
Okay, we gotta do 8. So we take 8 and subtract it from 15, we get 7.
Yep. And then you have to do 4.
So when we take 4 and subtract it from 7, we get 3.
You do 2.
When we take 2 and subtract it from 3, we get 1.
And then 1.
And that's 15 in binary code.
94.
Yay.
Does that make sense? All right, now, with that being understood, not understood?
Yes, I was shaking my head.
Okay, with that being understood, there's an alphabet. You can take this and write words and sentences and whole letters to people and be having it encoded where somebody can't really understand it. The alphabet goes just like the numbers, but instead of 1, 2, 4, and 8, you get A is equal to 1, B is equal to what? 2, C is equal to 3, D is equal to 4, E is equal to 5. So if my name was D, okay, if my name was D, I have to do this on separate lines. The D is on one line, the E is on the next line, and the last E is on another line. If my name was D, and the D has a value of what? I hear one person. D has a value of 4. How do I write D in binary code?
4,
The number 4. Now what happens to the rest of it?
0.
Zero.
So that equals the D. Now how do I write E in binary code? E has a value of 5.
So you use 4, 1,
I use the 4
and put 0 and 2.
and the 1.
That's a. Oh.
And you do the same thing. Yeah.
Yeah. Now when I write my name is D. Here's the bytes. I get 1 0 0 1 0 1 1 0 1, and that's D E E. Does that make sense?
Yes.
Now write your first name in binary code.
What her name is Deborah?
Whoa.
You got your age for half of your points. Write your name for the second half of your
So we gotta
points.
make our
You
own.
can have a 0 or 50 or 100. I am here to help you. I will walk around the room. The first thing I would do is what?
We got nicknames.
What's the first thing you would
Write
do?
it out like that.
Do your numbers. Do your table.
May I do a nickname?
No, I want your name.
It's my name.
Row 4. Do your table. Now you already started this table in Google Docs when we did your age. So it's already there.
My first thing was 5.
What about I? You make our own numbers?
Yeah, take the numbers and just go right on down. It's 26 letters in the alphabet, so you know what Z is. If you want to write it out so you can see it, that's fine.
All I gotta do is look it up.